Hello students, in this video I will be teaching you how to balance chemical equations. Now the first thing which you need to keep in mind is that for balancing chemical equation, number of atoms should be equal. Now the first chemical reaction is between hydrogen and chlorine, which gives hydrogen chloride. So first thing you need to write the atoms present in a chemical reaction both on the left side as well as on the right side. Now we observe that on the left side two hydrogen atoms are present as well as two atoms of chlorine are present. So we have to write the number over here. Now on the right side also we observe that there is only one hydrogen and one chlorine atom. Need to multiply on the right side by 2. Similarly we can see that the chlorine atoms on the left side are 2, whereas on the right side it is only 1. So we need to multiply here by 2. Now we get the same number of atoms on both left and right side. So whatever number we have multiplied over here, we have to write it as a coefficient in front of the compound which has been formed. Thus this chemical equation is balanced. Now take another example. Now this chemical reaction occurs between nitrogen and hydrogen, which gives ammonia as a compound. So we have to write the number of atoms participating in each of these sides. So on the left side we have 2 nitrogen atoms and 2 hydrogen atoms, whereas on the right side we observe that there is only 1 nitrogen and 3 hydrogen. By multiplying the right equation by 2 nitrogen can be produced. So whatever coefficient we are multiplying, we have to write as a coefficient in front of the product formed. Now we will check for the hydrogen also. On the left side 2 atoms are present, whereas on the right side 6 hydrogen atoms are present. Now we have to multiply this coefficient for both nitrogen as well as for hydrogen. So there are 2 nitrogen and 6 hydrogen. So in order to balance on both the sides, so 3 must be multiplied with 2, whereas the 2 will be multiplied by 3 in order to have 6 total atoms. So we have to write coefficient 3 on the left side. Now let us take an example of carbon and oxygen also. First we have to write the atoms, then we have to write the number of atoms. Now on the left side 1 carbon is present and 2 oxygen atoms are present, whereas on the right side 1 carbon atom and 2 oxygen atoms are present. Now this is already balanced. Now the fourth equation we have aluminium and oxygen atom. Now on the left side we observe that there is only 1 aluminium, and on the right side there are 2 aluminium atoms, whereas on the left side 2 oxygen atoms are present and on the right side 3 oxygen atoms are present. So we observe that in case of aluminium on the left side it has 1, whereas on the right side it has 2 atoms. So if we multiply this by 2, then we will get the same number of aluminium atoms. So whatever number we have multiplied over here, we need to write it as a coefficient in front of respective atom. Now for oxygen we observe that there are 2 atoms of oxygen and on the right side there are 3. So what do we need to do is, we know that 3 doesn't come in the table of 2, or 2 doesn't come in the table of 3. So we cross multiply these two numbers. We know that 6 comes in both of these tables. So we will multiply 2 by 3, whereas 3 will be multiplied by 2. So whatever number we have taken, we will write it as a coefficient in front of it. Now we have to check it once again after writing the coefficient. Now aluminium on the left side is having 2 atoms, whereas on the right side we have 4 aluminium atoms. If we see that there are 4 aluminium atoms on the right side. So now 4 aluminium atoms are there. So in order to have equal number of atom on the left side, we have to multiply it by 4. So we have to erase it. Now we have to multiply it by 4. So now check once more. Now the aluminium on the left side is having 4 atoms. On the right side also we are having 4 aluminium atoms. On the left side there are 6 oxygen atoms, whereas on the right side also we have 6 oxygen atoms. Now we have a balanced chemical equation. Now the last chemical reaction is with iron and oxygen, which gives iron oxide. So first we have to write the atoms participating in a chemical reaction. Now on the left side we have only 1 atom of iron and 2 atoms of oxygen, whereas on the right side we have 2 atoms of iron and 3 atoms of oxygen. Now if we multiply 1 by 2 on the left side, we will have equal number of atoms of iron. So 2 will be written as a coefficient in front of iron. Now the next atom is oxygen. Now on the left side there are 2 atoms of oxygen, whereas on the right side there are 3 atoms of oxygen. So if we multiply 2 by 3 and 3 by 2, we have 6 equal atoms. So whatever number we have taken for multiplication, we have to write it as a coefficient in front of the respective atom. So 3 will be written in front of oxygen. Similarly 2 is multiplied over here, so we have to write it as a coefficient in front of the product. So now look for the equal number of atoms once again when you write the coefficient, in order to check whether the chemical equation has been balanced or not. So now we observe that 2 iron atoms are present on the left side, whereas 4 iron atoms are present on the right side. So simply write 4 over here, but oxygen atoms are 6 over here. So this is correct. Now if we look on the left side, 2 iron atoms are present and 6 oxygen atoms are present. So oxygen is already balanced. So we have to erase the number for the iron. So we need to multiply this number by 4 in order to have equal number of atoms. Now this equation is completely balanced. Thanks for watching.